Hi, Benolde Eagles. This is Ms. Barker. We're going to continue our look at linear functions, just piecing together some of what we've recently been looking at. We're going to start with this function y equals 3x. So take a moment to copy down what I have, and then we'll get started. Okay, the first thing I want to do is rewrite this in standard form. Remember, standard form must be written as ax plus by is equal to c. So what I'm going to do is the y, I'm going to move it over to the other side. So if we subtract a y from both sides, the left-hand side is nothing but 0, giving us 0 is equal to 3x minus y. Well, now we'll adjust it to a 3x minus y equals 0, just a complete reversal. So this is now in the form of ax plus by is equal to c. Notice that one thing we tend to try to do for standard form is we do like for the coefficient of x to be positive. Also for standard form, notice that we do not have any fractions. Next, we're going to practice finding the x and y intercept. Remember, our method is we identify that we're going to find the x-intercept, we're going to find the y-intercept, and to find the x-intercept, that occurs when your y value is 0. When you find the y-intercept, that occurs when your x value is equal to 0. Alright, so from here, x-intercept occurs when y is equal to 0. If you put 0 where the y is, that's going to make this part go away, giving you 3x equals 0. Divide both sides by 3, we get x equals 0. Now let's consider our y-intercept. That occurs when x is equal to 0. Substitute 0 in place of x, so this part's gone, giving you a negative y equals 0, which of course gives us y is equal to 0. So now we have the x-intercept and we have the y-intercept. We can tell looking at this that this graph is going to end up going through the origin. It's going to go through 0, 0. The next thing we're going to practice is making a table of values. What I want to do specifically for this table of values is we're going to end up with 5 values in our table. Right in the middle of the table, I want the x-intercept. I want 2 values to the left and 2 values to the right. We'll go back to the original y equals 3x. We'll go back to the original slope-intercept form to help us out. Notice we don't have any fractions, so we don't have anything we really have to pay attention to. One thing I've noticed some of you struggle with is figuring out what am I going to use for my x values. It honestly does not matter. We may as well keep it basic with a -1 and a -2. And as far as on the right-hand side, I'll go with a 1 and a 2. But quite honestly, we could have used any numbers we wanted. Now let's do some substitution. -2. 3 times -2 is -6. So I'm taking the -2, substitute it back into this equation. So 3 times -2 is -6. So that tells us that when x is -2, y is -6. For -1, substitute it in. 3 times -1 gives us a -3. For 0, 3 times 0 gives us a 0. For 1, 3 times 1 gives us a 3. For 2, 3 times 2 gives us a 6. So that gives us a table of values. Now, we could plot those points, and if we were to plot the points, we would end up with this being our graph. I want you to notice that we can use our table to confirm our table of values. When x is -2, y is -6, and so forth. But I want you to notice we could have chosen any x value and we would have been getting y values back. So don't stress as much as you sometimes do about what x values are we going to use. You may as well keep them reasonable. But quite honestly, since the domain is all real numbers, we can use any x values that we want. The next one I want to consider is y equals 5. Alright, so we're considering y equals 5. For this one, Again, standard form. ax plus by is equal to c. Well, I don't have an x, so this is it. We have no x's. Here's my y is equal to my c value of 5. So it's already in standard form. We're already good. We'll get set up for the x-intercept and for the y-intercept. Remember, the x-intercept occurs when y is equal to 0. The y-intercept occurs when x is equal to 0. Yeah, well, when it comes to the x-intercept, I already said y is equal to 5. So that tells me y is never going to be equal to 0. So I do not have an x-intercept. On the y-intercept, when x is equal to 0, well, no matter what, y is equal to 5. So my y-intercept is that my y value gives me a 5. Creating a table. Here's my x, here's my y. I'm going to have 5s throughout. And when it comes to the x values, it really doesn't matter. -2, -1, 0, 1, and 2 is good enough. If you want to consider what that what that graph is going to look like, this is the special case of the horizontal line, to where no matter what, your y value is equal to 5. My table would look like this. No matter what my x value, my y value is always equal to 5. All right, let's consider another one. For this one, I want to take y is equal to -3x plus 6. So right now it's in slope-intercept form. I want to change it to standard form. Remember, standard form is ax plus by is equal to c. So this -3x, I want to move it over. If I add 3x to both sides, that gives me a 3x plus y equals my 6. All right, so 3x plus y is equal to 6. So now this is in standard form. Once we have this in standard form, let's find the x-intercept. Let's find the y-intercept. Remember, the x-intercept occurs when y is equal to 0. The y-intercept occurs when x is equal to 0. Notice just that standard setup each and every time. Y equals 0 in my standard form. I have 3x plus, now that's going to be a 0. So that gives me 3x is equal to 6. If we divide both sides by 3, we get that our x-intercept is that x is equal to 2. Now, for the y-intercept, that occurs when x is equal to 0. So we're going to go back to our standard form. And so where I have my x, substitute in a 0. That leaves me with y is equal to 6. Now let's create a table of values. We're going to use 5 values in our table. And as far as y, it's simply because that's what I'm asking for. I'm asking for a total of 5 values. And what I'm choosing to do, I'm choosing to take the x-intercept, and I'm going to put that right in the middle of those 5 values. So what I'm asking you, what my directions to you will be, is I want 2 values to the left and 2 values to the right. So I may as well, since I don't have any fractions involved, I may as well have a 0 and a 1. After my 2, I may as well have a 3 and a 4. So if I go back into the original, y equals -3x plus 6, that was my original. If I substitute 0, -3 times 0 is 0, and 0 plus 6 is 6. Now let's consider when x is equal to 1. -3 times 1 is -3. -3 plus 6 is 3. Now let's consider when x is equal to 2. -3 times 2 is -6, and -6 plus 6 gives me 0, which is good because this was supposed to be our 0 of our function. Consider when x is equal to 3. -3 times 3 is equal to -9. -9 plus 6 is -3. And now let's consider when x is equal to 4. We have -3 times 4 is equal to -12. And -12 plus 6 will give us a -6. Okay, make sure you have that copied so far. Okay, so now that you've copied that, let's consider the original equation. Y equals -3x plus 6. Okay, so let's consider the graph of this. If we graph it, we have a line. Notice that we identified that the y-intercept should occur at y is equal to 6. We identified that the x-intercept should occur at x is equal to 2. By the way, one way I can check that work, second, calculate, number 1 for value. I'm going to put 2 in for x. Notice when x is equal to 2, y is equal to 0. For that matter, we can check our y-intercept. Second, calculate number 1 for value. When x is equal to 0, notice that my y is equal to the 6. Plus, we could go to our table, and we can confirm the table values that you came up with. All right, let's take a look at another one. Here's our number 4. For this one, we're going to consider y is equal to 2/3 x minus 4. One thing I've pointed out for standard form is that I do not want fractions. I've got a fraction here. I'm going to multiply both sides, therefore each and every term, by 3. So y times 3, I've got a 3y. 2/3 x times 3, my 3's are going to cancel, giving me a 2x. That's why I chose 3 in the first place. -4 times 3, I can write a -12. So step 1, I do not have fractions anymore. Next, we need to start moving things over. So I could subtract a 2x from both sides. -2x minus 2x, giving me -2x plus 3y is equal to -12. Finally, for standard form, it is preferred that we do not start with a negative. So let's just multiply both sides, therefore each and every term, by -1. If we do that, we change all the signs. So now we have 2x minus 3y is equal to 12. Now our function is in standard form. Okay, so what I want you to do, pause the video, and I want you to find the x and y intercept from the method that I've been showing you. All right, so let's check the work. The x-intercept, y is equal to 0. Put 0 in for y, you should have gotten 2x equals 12. Divide both sides by 2, you get x equals 6. For your y-intercept, your x is equal to 0. Put 0 in place of x, you would end up with a -3y equals 12. Divide both sides by -3, we get y equals -4. So, take a moment, make sure that this is accurate, and set up your table. Pause the video, and we'll come right back. All right, so remember I was saying that I want for the x-intercept to be in the middle. Then we're going to have 2 values to the left, but let's be careful. Our standard form is y equals 2/3 x minus 4. Notice that when x is 6, you have 2/3 times 6. 2/3 times 6 is going to give you 4, and 4 minus 4 is 0. So that works out nicely. But if we had tried, say, something like x is equal to 5, we're going to be stuck with a fraction, and I would rather not. Let's consider our denominator of 3. If we take 2/3 times 3, our 3's would cancel out, giving us a 2 minus 4, which is equal to -2. And by the way, yeah, when x was 6, y was 0. So notice we can skip by 3's, meaning I want to use a 0, a 3, a 6, a 9, and a 12. Take a moment to do the calculations, pause the video, and we'll do our check. Okay, check your work. By the way, these calculations I am showing this time around, you do not normally have to show them, but I know sometimes you guys are struggling with some of these calculations, so I'm just giving you this extra piece of information. I'm glad that you took care of your notes. See you on Monday.